master gauge setting fixture for dial bore gauges. So what we need to do now is we need to set our dial bore gauge to fit the master, which is what we set the cylinder at, which we measured now at 5 inches, 117 thou. So on the scale here, the gauge point scale that we looked at earlier, we need to find the correct dimension at 5 inches, and the scale here says 5 inches to 5.375. So those are the gauge points that we need to use, which is gauge point number 7 and gauge point number 4. So if I look in the box, I'm going to pull out gauge point 7 and 2 and 4. Now we're going to take a little tool here, take it apart. And we're going to put in our gauge point 7 into our dial bore gauge. And with the little supplied wrench, we're just going to lock that up so it maintains accuracy. And then we're going to take number 4 gauge block, which is the adjustable portion, which gets us to the size that we're trying to establish. So now, taking a look at the master gauge fixture, we know that the measurement is 5 inches and 117. This gauge block here shows that it meets 5 inches. Okay? It's a little odd when we look at some of the tooling that this one is 5 inches and this one is actually 2 inches. But it's these gauges here that are making up the difference in the measurement between the master gauge fixture and the dial bore gauge that we are trying to set up to measure the cylinder. So we're going to use the 5 inch because we know that the manufacturer's bore spec is 5 inches, 122 thou. And we've actually established that the cylinder dimension is 5 inches, 117 thou. So if we set the gauge at 5 inches, 117 thou, we can read up to and hopefully not beyond the 5 inches, 122 thou. So now setting the 5 inch block in place, we've dialed on the scale 117 thousandths of an inch. And we use a very large magnifying glass on here because this actually reads in half thou increments throughout the scale. So we can pinpoint it right down to a half thou value based on manufacturer's specifications or required settings through measurement. So now I'm going to take the assembly that I've put together with the 7 inch gauge block, the 4 inch gauge block, and we've already set the measurement at 5 inches, 117 thou. On this gauge also we can pivot this so that it allows the anvil right here to move over center of the tool. So we want it to be right in the very middle so that we're reading accurately on setting the tool up to get the precision measurement we're looking for. So when I set this in, I'm going to take the play out of the gauge. I'm going to make sure that it's sitting square across the face. And then I'm going to make an adjustment and lock the tool. Lock the tool. Put it back in, take the play out of it, and the tool should be sitting at now right on 0. Okay, so now the tool is set up to read 5 inches, 117 thou, and beyond on the scale. Now the tool itself, the increments on the tool are in half thou increments. So each line that we see indicates half a thou of wear. So 2 lines would equal 1 thou of wear. 4 lines would equal 2 thou of wear. 3 lines would equal 1.5 thou of wear. So now what we're going to do is, now that we've established the dimensional value on the dial bore gauge, now we're going to take a look at it in the cylinder. And what we like to do is put the gauge in and then collapse it so that we can actually put it down into the bore. And I'm going to start with this one tipped and roughly about mid-scale. So what we want to do is, when we're checking this, is we don't want to be off center like this. We want to be 90 degrees parallel to the cylinder liner. This allows us to read accurately across the gauge face. So taking a look at this now, we want to rock it into the positive, into the negative measurement. And when it stops, noting that we're at 90 degrees, we can read 1, 2, 3, 4 increments on that scale, which is 2 thou of clearance. We've established that the measurement is 5 inches, 117 thou, plus the 2 thou is now 5 inches, 119 thou. Still falling within manufacturer specs of 5 inches, 122 thou. So what we need to do is we need to travel down to the bottom of piston ring travel, check the dimension. We have 3 there. Travel up, tipping the gauge so that the gauge does not mark the bore, and then again to where the manufacturer says to measure, and we see here that we have 4 on the scale also. So that is one dimension. Okay, so we had 4 thou, or 4 increments, which is 2 thou, 3 increments being 1.5 thou, and 4 increments being 2 thou. So we have equal amount of wear at the top, equal amount of wear at the bottom, and nominal wear in the middle of the cylinder travel, which is typical of all operation of cylinders. So now what we're going to do is we're going to turn it 90 degrees. And the reason that we do that is because the cylinder in the engine, if the piston is moving in this direction, we're going to wear across these 2 surfaces. This is the major and minor thrust area. This area, front to back, is where we also get wear in the cylinder from when we press the clutch in and we rev the engine out. The gears and the crankshaft tend to move back and forth during operation. That causes the piston to move back and forth, which causes the cylinder wear in this direction. So if we were to take a look at it, how it's wearing, it's starting to wear like this, which is an egg shape. We call this dimension out of round. The taper is the distance, or is the difference between the top measurement and the bottom measurement across 2 planes. That difference between the top and the bottom is our taper. The difference between top, middle, bottom on one axis, top, middle, bottom on the other axis, the difference between those 2 measurements is our out of round measurement. Okay? Both are supportive to specification and requirements by manufacturers for permissible values. So if we go ahead and we check this dimension now, four, which is 2 thou, 4, and 4, which is 2 thou. Okay, so on this direction, we only have 2 thou overall of this difference between top to bottom. So no noticeable difference. The other plane, we had a slight difference between the top and the bottom and the middle. So that's also a good indication to the technician, if he didn't mark the cylinders when he took them out, that the position that creates the most amount of wear would be from movement back and forth in the bore. So relative to what we measured, this would be the correct position. That cylinder would be reinstalled or removed. So when we calculate these measurements, we need to check it top, middle, bottom, create an average. Then we turn it on the second plane, measure top, middle, bottom, and get the average. The distance, again, or the difference between A axis average and B axis average is our out of round. The difference between the top AB average and the distance between the bottom AB average is our taper. So the distance from here to here, which shows that in the cylinder. Okay? So that's the use of the dial bore gauge, the master gauge fixture, and how we're going about establishing correct measurements in the cylinder. A lot of